shows how to model a reinforced concrete structure efficiently in Revit in just 5 minutes, including gridline layout and level placement. As shown in the section view, the columns are modeled separately at each floor level instead of one continuous element for better scheduling and for better 4D simulation, as in real-life RC columns are casted for each floor separately. Now, let's start modeling by setting the levels first. To speed up the workflow, the Array tool is used to create multiple floor levels quickly instead of placing them one by one. This is especially useful when the project contains many levels. As shown, the new level bubbles appear in black, which means floor plan views have not been created yet. To activate these levels as floor plans, select the levels and create the corresponding views so they appear in the project browser. The next step is to create the grid layout and start building the structure, beginning from the foundation. For placing the grid lines, Array tool is also used to speed up the workflow. This helps create multiple grids quickly and maintain consistent spacing across the entire structure. Now let's place foundation footings. The Place at Grid tool is crucial for quickly placing structural elements accurately at grid intersections, which speeds up the entire modeling process and improves alignment control. Footing didn't appear as I need to fix the view range in the plan. Now let's place the foundation column's neck, solidering from foundation level to level 1. Duplicate the original element and rename it, since separate columns are required for each floor level. Make sure to set the height properly. The foundation construction is now completed. Next, we will move on to the upper structure. Let's add the columns from level 1 up to level 2. Place at Grid is an important tool, because it automatically positions elements exactly on grid intersections, ensuring perfect alignment with the structural layout. It reduces manual errors and saves time. Duplicate the original element, and rename it, as we want separate columns for each floor. Now, let's add the ground floor and offset it by a value equal to its thickness so that the bottom of the slab aligns with level 1. Let's create a section to check how the floor is placed and verify its alignment with the levels. The floor base offset is set to the slab thickness of 200 mm so the bottom of the floor will align with level 1. Finally, the columns from floor 1 and the flat slab are copied and pasted to the other levels to complete the structural repetition across the building. This method is very important as it ensures consistency between floors and significantly speeds up the modeling process in repetitive structural layouts. As a final touch, I will delete the columns on floor 4 as it is planned to be the roof. To select only columns on floor 4, go to Floor Plan and select all columns visible in view and delete them. Lastly, let's create the topo solid for better visualization. As a final touch, for better organization, I will duplicate and rename the columns on floors 2 and 3 so they appear as separate elements. So what I will do is go to the floor plan, select all visible instances, make sure it's not all an entire project. Then duplicate and rename them according to the floor level. This keeps each story organized as a separate set of elements, making the model easier to manage and modify.